Welcome to our lecture online. Here we're going to yet learn another way of finding the determinant of a matrix. We're going to do so by reducing the matrix to what we call the echelon form. The echelon form is where the lower left, and typically the lower bottom left of the matrix is all zeros, and we have the diagonal and numbers on the other side of the matrix. You'll see in just a moment what that looks like. We're going to do that by using the typical methodology. We could interchange rows. We could divide or multiply any row by any constant, and we can multiply any row by any constant and add that to any other row. But this method here, where we're first going to try only by what we call row addition, meaning we're going to multiply a row by a constant and add it to another row, and not interchange rows and not divide or multiply a row by a constant, then you'll see that what we end up with, we can very easily find the determinant of the matrix. But if you interchange rows or you divide or multiply a row by a constant, you'll have to do something to the answer in order to get the correct value, and we'll show you that in the next video. But here what we're going to do first is take this 2 by 2 matrix, reduce it only by using row addition to the echelon form, and then you'll see how we can find the determinant of that matrix. To have something to compare it to, let's first do it the old-fashioned way. Take the determinant of the matrix, A, and that is equal to the product of those two, minus 3 times the minus 1, minus the product of those two, minus 3 times the positive 6. So this would be 3 minus a minus 18, that would be plus 18, which is 21. Now we're going to reduce this to the echelon form using our typical methodology, except we're not going to use these two steps right here. We're only going to multiply one row by a constant and add it to another row. To get rid of the 6 right here, what we could do is we can multiply the first row by 2 and add it to this row. So what we're going to do is we're going to take the second row and replace it by taking twice the first row and adding it to the second row. This is the step where we do row addition, so we don't have to do anything to the answer when we get the final form. When we do that, we get the following matrix. So this becomes equal to, notice that the first row doesn't change, that stays the same, but the second row now changes. 2 times negative 3 is negative 6, added to 6 gives me 0. 2 times negative 3 is a negative 6, added to negative 1 gives me a negative 7. Now notice that this is indeed in what we call the echelon form. What that means is that the lower bottom left of the matrix is all zeros, we still have the diagonal, and we have numbers in the upper right portion of the matrix. Then we can say that the determinant of that original matrix A is equal to the product of the diagonals. In this case, that's equal to minus 3 times a minus 7, which indeed is 21. Notice we get the exact same result as we had before. Therefore, if you take a matrix and you reduce it to echelon form only using the row addition step, and you don't use the other two steps, what you then end up with is you end up with a diagonal that if you multiply those elements in diagonal together, you will get the determinant of the matrix, just like we did with the other methods. Now what happens is, if you interchange a row, each time you interchange two rows, you will have to multiply that answer by negative 1. And each time you divide the row by a constant, you will multiply the answer by that same constant. Or if you multiply a row by a constant, you'll have to divide that same answer by that constant. And we'll show you some examples of how to do that in the future videos. But at least this is how you can see how you can find the determinant using the echelon form. And that's how it's done.